And you're listening to Tech Radio, a source of news and commentary about technology and science. You can hear us each month with the podcast at Tech Radio, or if you live in mid-Missouri on KOPN Columbia 89.5 FM on the third Sunday of each month at 11:30 p.m. This episode, we have Brad,
Hey, everybody.
and we're going to concentrate on a single story that's been, I don't know, hitting us for the last year or two as some exciting developments have come out, and that is regarding solid state batteries. This is very much, it's not a new technology. In fact, lithium ion, ironically, is the newer technology, which we'll get into here in just a little bit. But they're finally getting solid state lithium batteries to work, and that's really big news, both for cars and the aviation industry. But if you're right with it, Brad, I've kind of like done more research than I normally do, and I've got kind of an explanation of what this is about from a chemical and mechanical point of view.
Oh, by all means, educate me.
Yeah, and I'm going to do something that's going to be backwards than most of the stuff you see out there on the internet. I'm going to start with the solid state batteries because that's actually what they started first, and they make much more sense. And then we'll see the hacks they did when they made the lithium ion batteries and why they did it, and then why they've now finally found a way to do it the better way, the solid
Okay.
state. And by the way, the naming is somewhat misleading because both solid state lithium batteries and lithium ion batteries use lithium ions. But let's get back to the basics. On any battery, you've got an anode and a cathode, a positive and then a negative side to the battery. And those are
Right.
just simply metal sheets. That's where you collect or emit the electrons from. And in between is the actual battery part between those two sides. Now, for a solid state lithium battery, the cathode is actually made out of lithium metal. And kind of jump back to the days of chemistry for those who remember your high school chemistry. On any atom, you've got various valence shells. So, like helium and hydrogen occupy the first valence shell. And then you've got each shell around an atom has room for so many electrons. It's two, then eight, and eight, and eight. And then I think it jumps to 16 or something like that. Um, Lithium holds a very special place in the periodic table because other than hydrogen, and nobody wants to make a battery out of hydrogen, that would not be good. Talk about
Right.
explosive. It is the smallest and lightest element that is still a metal and yet has exactly one electron in the outer valence shell. And so lithium on the periodic table is element number three. It's hydrogen, helium, lithium. And so lithium has three protons in the nucleus and then two electrons filling the first valence shell, so it's happy. And then in the outer shell above it that wants eight electrons. In fact, if you fill all eight, you get neon, which has 10, is the 10th in the table. But lithium only has one in there. So when lithium floats around by itself, it acts like it's a positive ion. That it's got a charge to it because it's got that free electron just spinning around that outer shell, wanting to connect and combust with other things.
Hmm.
And so it's a very reactive metal. And so what they do is they take advantage of that. And when you put a charge, when you're charging up the uh, the lithium metal battery, what you're doing is one of the cathode, what is actually made out of lithium, and then you have some kind of barrier that it has to cross, a separator of some kind, typically a porous barrier, so that it takes a certain amount of energy to jump across it. So when you're charging the battery, you're actually compelling the lithium ions to jump, that disassociate from the metal and jump out as an ion and cross that barrier into, I would like to think of it as a soup, a storage place for those lithium ions. And that's usually what they call an electrolyte. So it's a chemical mix of some kind, and it jumps into that electrolyte, and that's the holding place right before the anode plate, which is the other side of the battery.
Okay.
And so as you're charging it, you're literally yanking lithium atoms out of the metal and into ion form and into that electrolyte. And that's how you're storing those charges. And then when you go to discharge the battery, you put a conductor around it, so it's actually completing the circuit, and that gives the opportunity for those lithium ions who don't want to be there to jump across that separator back into the lithium metal. And so that's how a lithium battery works. You're pulling it out of the metal, and then it wants to go back to the metal and when you finish the circuit, bam, it jumps back and you have electricity.
Okay.
Now, the problem with this is what happens when it crosses that barrier? Where does it land on that lithium metal plate? And it's just a fundamental law of nature that systems always go to the point of lowest energy. Where's the least amount of energy to jump across that plate? Well, the place that that's closest across the barrier. And so even if you make that barrier perfectly smooth and that lithium plate perfectly smooth, there's going to be one atom that's closer than the other ones because nothing in the world is perfect. And so the lithium atoms are going to jump and connect to that one spot. And so the next charge and research cycle, where's the next set of atoms? Well, you've already got a spot that's a little bit taller than the other spots. So guess where the new atoms are going to go? They're going to go to that spot. And
Okay.
eventually you're going to start to form what looks like stalactites. It's going to create what they call a dendrite, but it's kind of like how you see stalactites and stalagmites form in caves. Energy, the water rolls to the lowest point before it drips off. And so that very action creates over and over again, it creates, and then of
You're
course in a cave,
depositing lithium right back in the same spot over and over
over
again,
and over again, you're pulling
building
it
up
from
on the
all over the
previous.
place, but you're pushing it back into one spot or many tiny localized spots.
Uh-huh.
And so just like in a cave where a stalactite growing from the bottom and a stalactite growing from the top, if it do it long enough, eventually they touch. But when it comes to electricity, that touching is a short.
Right.
And
Okay.
now your battery's on fire. You don't want that. And that was the problem with lithium batteries, is that they couldn't get them to not catch on fire. And so they came up with a workaround for that. And that's where we get into lithium ion batteries. What they do is not only does the anode side have this electrolyte, this soup that's semi-conductive that they can hold the lithium ions, they put another soup on the other side. And instead of making the cathode out of lithium, they make it out of just a regular conductor, like copper or something like that. And they fill that soup on the other side with little nuggets of lithium alloys, and it's mixed in with another soup of electrolyte on that side. So there's electrolyte soup on both sides. So it's very much a liquid. And I say liquid, and you're not going to be able to pour it out, but it's wet in nature. It's
Like
very
a paste.
mobile. Yeah. And so it makes it harder to form those dendrites. So more accurately, you still form the dendrites, but there's a lot of them. There's not one big dendrite.
Ah, okay.
You're loaded with lots of tiny little ones. And essentially, a lithium ion battery can be charged and discharged over 1,200 times safely, which doesn't sound like a lot when you first hear that. But if you think about it, if you're just charging your cell phone once a day, 1,200 charges is a lot of years.
Yeah.
I mean,
Yeah.
that thing's going to last a while. And there's other things you can do because you can put a bigger separator in there. The problem is the more you separate things, the less efficient the cell becomes. But now what you have is you have two big pools of electrolytes on both sides. That separator that's porous in the middle, and then you got your two cathodes. But it works, and that's why we have them today. It's a workaround that works. What they've done recently is they found a new way to do that separator, but instead of it being porous, it's actually a ceramic. And I can't explain it on the air how that works. I don't know that they know how it works. I'm sure I say that. I'm sure there's some chemist out there that'll give me some long explanation that doesn't make any sense to me. But that barrier that they're putting up now still allows the lithium ions to cross over. But when they form into the metal, because it's a solid barrier, it presses against the barrier. So it can't form a dendrite. Even if it tries to pop into the same spot, there's too much pressure against it and it'll go somewhere else.
Okay.
So essentially, they're squashing the lithium metal flat. So the benefit of that is now you don't need that soup on the anode side. So literally, the battery is half the size and half the weight, which
But
is
the
a
same
huge
power
bonus.
density.
Same power, right?
Okay.
So, well, actually increased density, but same amount of power for any one particular area of surface. So yeah, literally the same amount of power in a battery but it's half the size and half the weight. Now there is one downside to it because that ceramic conductor isn't perfect. Nothing in the world is perfect. It does reduce the number of charge and recharge cycles. So instead of 1,200, they're seeing somewhere between 500 and 600 charges and recharges. So
Okay.
for certain applications, it's kind of a wash. more density and less weight, or but you have to replace it more often? So the first people to purchase these batteries is a very select group that's willing to spend the extra money it costs, and they're willing to replace the batteries more often. But it turns out, and this is why these companies are very excited, there actually is an industry that really wants these batteries, because for them, weight is everything, and that's the aviation industry.
Mm. Hmm.
They know that regulations are coming down the pipe, and they know that soon enough there's going to be taxes and restrictions on flights, and they don't want their industry messed with. So if they could come up with an electric airplane, that would make a huge difference. The problem is you can't do electric airplanes today. Actually, there are some coming out, but they're small planes with limited range. But if you can cut the weight of the battery literally in half, that opens up like they can't do still like international flights that way, but you could fly from, in theory, Kansas City to Chicago easily with the weight difference.
Mm.
And the other irony is that and I didn't know this because this, again, getting into the research of this, 30 to 35% of the cost of your airline ticket is engine maintenance, because every so many hours on an airplane, they have to take the engine out, take it all apart, clean it, refurbish it, and put it all back together again. It is very, very expensive to maintain an airplane. That all changes with electricity because there's only one moving part in an electric motor, and that's the rotor. Everything else is solid state. So you
Mm.
only have to cleaning the rotor up. So instead of them spending, I don't know how many hours it takes to refurbish a airline jet engine, all you got to do is take the rotor out, clean it, and put it back in. That's a game changer for the airlines. That's a
Yeah.
huge cost difference. That's ignoring the fact that they're also going to get a benefit of less fuel. So for them, replacing the batteries every 4 years is nothing. They could care less about that almost
Well,
compared to
yeah,
the
and I would think
benefits.
that
Yeah.
it's really not a big deal for anybody if the device that's using it is designed for replacing it. I mean, if I could
Yes.
get 600 charge cycles on my Tesla and then replace the entire battery pack and it was recyclable and and not a big deal to change out, then I don't
Yes.
really care if it's 600 cycles or 1200 cycles.
It
I mean, if
appears
it's
these things are
easy
much
enough
more.
and the cost is low enough.
They they're not saying this, but that was saying that they're using these alloys in the lithium ion batteries. That's where you get into the whole discussion of where's an ethical place to get cobalt and nickel and all the other metals they're working with. Lithium
Mm.
metal batteries don't have those nodes in it. And so that removes all of their sourcing problems too. So yeah, you can see that there's a lot of players involved that are just very, very excited about this because it just changes the game.
Oh, absolutely, yeah.
Uh,
So, I mean, are cell phones and mobile devices a target market for these newer batteries?
they will be. I mean, those are when you start when I first started researching this, that's what I was thinking. I was thinking, well, cell phones and cars; those are the big consumers of lithium-ion batteries, right? And not so surprisingly, I'll give you the names of the three companies that are starting to hit some real strides here and are likely to come out within the next 2 or 3 years, actual production facilities. Probably the first one to come out with it is Samsung, although Samsung is not Samsung, I'm sorry, too many corporate names. Toyota.
Okay.
Um, Toyota has been very, very secretive about their solid state power program, but apparently, rumor mill is they're close. It is partly why they've not done, because I've always wondered this. They're one of the first people to come out with the Toyota Priuses and the electric hybrids. Why aren't they doing a fully electric car? It's apparently because of this. They've been waiting for the solid state ones to come out because they've been putting a lot of money and effort into getting it into production. And so Toyota is one of the big players. Um, the other two big ones are Solid Power. That's a company backed by Ford and BMW, along in cooperation with another company called Volta Energy, who's also been putting some research backing into it as well. And then QuantumScape, which has apparently a large number of other backers, but the biggest one being Volkswagen. And uh, and it's kind of ironic when you read the stories that they're talking about. they're backed by the car company. So sure enough, they mention how it's going to be great to put in the cars. But and then you read another article where they're talking just to like the CEO of the research company, and they know it. They get excited about the aviation industry because they know
Hmm.
those are going to be the first customers. Um, and so yeah, this will be very interesting to have electric planes. Now, what's not known is public acceptance of it. People really like jet planes because it feels comfortable to them. Um, the electric planes, they're propeller planes. Are people comfortable with getting into a airplane with propellers on it? I know
Well,
if
it
they're,
depends. I mean, are you talking, local commuter hops? Are you talking transatlantic flights?
yeah, yeah,
I mean, I don't. I mean, unless this is as fast as a jet and isn't going to increase the number of stops, I'm not. I wouldn't be looking for one on a transatlantic flight. But
yeah,
I don't think I'd have a problem with it having propellers if everything else was the same.
yeah. And there really shouldn't be too much of a time difference between the two. I mean, in the end, you're limited by the speed of sound. There's there's just a speed in which you get diminishing returns on your flight when you start going faster, and you
Hmm.
can't go over the speed of sound because that's regulated and that kind of stuff anyway. And so yeah, the prop plane. I mean, it's not going to be like like a World War II era or World War One era prop plane.
Right.
I
I
mean,
mean, we
it's
got we got turboprops that
yeah,
fly from Columbia to St. Louis all the time.
yeah, yep. And so, yeah, that's likely the future of avionics is to have solid state battery driven electric planes. And there's a lot of players involved, really big ones that are doing the research and gearing up to go down that direction.
So I was surprised that you didn't say that Tesla was a player in this as well. I mean, they've poured an enormous amount of money into their
Yep.
battery production capability.
Yeah. Here's the thing. I don't think solid power or quantum scape are going to have any problems sharing a little bit with Tesla.
Uh,
So will Teslas take advantage of this once these things go into actual production? I suspect they will. But no, Tesla's been concentrating on making the lithium ion ones better. And they're making pretty good strides. I forget how much it was last year when they were doing their conference, but they're showing a new method of with larger batteries where they're going to get about a 20 to 30% improvement in density and power and reduction of cost.
yeah, that's their what do they call it? Their jelly roll.
Yeah,
So the battery is basically has the anode and cathode laid out in a with the electrolyte in between, and then the whole thing is rolled up. So you have an anode and a cathode along the entire. Instead of having just one on either end of a large blob of electrolyte, you've got it throughout the material, which allowed like 3 times the charging speed. And
right.
but the real challenge was being able to manufacture them in volume. So they just poured billions of dollars into the gigafactory in order to make these batteries because they're seeing the strategy here, not just being able to put the batteries in the car, but be able to put them in their power walls, and so it's I forget what they talked about, the number of terawatts of electric storage that's necessary over the next
Yeah.
10 years to facilitate a transition to electric vehicles.
Yep. Yep. And there's also, by the time you're wanting to get rid of the battery pack out of a car, say you only have 80% capacity, you can get down to about 60% capacity before you're in any real danger of the shorting occurring. Uh, I suspect there's going to be a large market also with the way they're doing the batteries of recycling them into power plants.
Right.
And so they'll be continued to be used as a battery, but it's time to replace the
And I
replace
don't
the
think there's
batteries that are.
anything
So go
in
ahead.
those batteries that isn't recyclable.
No, no, they're actually very. That was one of the things that because you get a lot of weird stuff talked about on the internet, but one of the things that goes back to over and over again is that because of it's because of the limited number of things, and most of them are metals. Metals are very recyclable.
Right.
It is not a horrifically complex process, and it's usually profitable. People will argue about recycling of bio waste and plastics and that kind of stuff, but no one out there is yelling about aluminum, for example.
Right. Yeah.
No, no, no. Let's recycle the aluminum. That's there's a lot of places that will gladly take your aluminum, all the aluminum you have for free.
Sure. Absolutely.
They'll melt
And
it
these
down and
batteries,
sell it
it's nothing
again.
that's in the batteries. It's being used up. It's just like you say, these dendrites forming. So
Right. It's
you
a
know,
structural problem. So if you melt it down and put it back together again, yeah, it's a brand new battery. And they're
yeah.
atoms. So it's not like you'll wear out an atom.
Right.
They've been around for how long has the universe been around now? 12, six
Oh,
billion years or something?
quite a long time.
Yeah. Yeah, but our atoms are not wearing down. So and none of this is nuclear, so they're not forming different kinds of atoms. So no, it's 100% recyclable. And it being a solid state material, yeah, don't get me wrong. I'm sure there's quirks between the recycling process of with electrolytes in there and all that kind of stuff between one form and the other. One is but the biggest, most important parts of it, the metals are very recyclable.
Hmm.
Yeah, and if it's yeah, and I suspect this will also be true to some degree with the solid state batteries too. By the time you don't want it in your phone anymore, it makes sense, especially if they're using standardized cells. Um, Although I say that out loud, most cell phones don't have standard size cells. They're usually custom shaped, aren't they?
Well, yes, but now that we are moving closer to right to repair, it may be that there's more of an incentive for them to use standard
Yeah,
size cells.
yeah, yep. By the way, I didn't have this in my notes. All three of these players, including if again stuff out of Toyota's rumor mill, so take it with a grain of salt. But with solid state Toyota and solid power, excuse me, Toyota and QuantumScape, they're all not doing the cylindrical cells. They're starting off with flat packs.
Ah, okay.
That may change as they get better at the manufacturing process, but apparently what they're even with the current lithium batteries, that doing the rolled cell is more difficult to manufacture. And so starting with the flat packs makes a lot of sense. I mean, you don't get a size downside, they're just harder to work with. Because
Hmm.
when they're flat, there's a lot more wiring to get done. But yeah, version ones will be flat. And now this will be some exciting stuff to watch. And the big reason I wanted to talk about this on the show is that it's leaving the labs. It's actually they're building factories now. So they're
Okay.
starting to scale it up. And so this is not a if it was is seen one day, it's more of a when we see it one day. With the gotcha that there's not we've seen more than one technology in the past that works great in the lab, and when you manufacture it, there's enough defects in it, it's not worth doing anymore once you've built the factory, which is a very hard time to learn that lesson.
Yeah, yeah.
Oh, we built a $20 million factory. Yeah, it's not going to work well.
Probably don't want to build that factory until you're sure that you can manufacture these reliably and that they have a lifetime in a market. But
Yeah, you got to start somewhere. I mean, even Tesla did that with their first. They created a little micro factory for the Jelly Roll
mhm,
batteries. They actually got it running. In fact, when they did that announcement, they were already in production of those batteries from the
yeah.
small factory. So they were fairly confident at that point that they can make a big factory with it. Yeah.
So, any idea what the first products that include these new batteries is going to be?
It will likely be first. Well, like I said, I suspect it'll be the airline industry. The only big question mark on the airline industry is, of course, will Boeing and the other players that take advantage of this, how quickly will they start producing electric airplanes that can use it? So there may be a bit of a gap there.
Well, I would
Um,
expect that the airplanes are the big market, but I don't think they'll be first movers because the
yeah,
airlines are going to be conservative and they're going to want to see, you know, a long history of reliability in the batteries
yeah.
before.
It's possible that the first players we see doing this will be the cars.
Yeah.
I mean, it's not a coincidence that these are all being backed by car companies.
Right. Yeah.
I mean, they intend to use it for themselves. Well, that was the subject for today. Thanks for listening. And as always, take care.